Each year, millions of patients undergo bladder function studies which employ urethral and rectal catheters to aid in the diagnosis of lower urinary tract symptoms and benign prostatic hyperplasia. Catheter use is uncomfortable and can cause complications such as urinary tract infections in some patients. The uroNIRS 2000 bladder monitoring system applies near-infrared spectroscopy, or NIRS technology, to monitor oxygenation and hemodynamic changes in the bladder detrusor. These microcirculation statuses differ in healthy and diseased bladders, and this can be detected during voiding by characteristic NIRS signals. Combined with measurement of Qmax and PVR, the system provides a functional evaluation of the bladder during voiding to aid in the diagnosis of bladder outlet obstruction. This method is non-invasive. This method is accurate. Clinical study results show 86% sensitivity and 89% specificity for detecting bladder outlet obstruction. This method is efficient. The test is easy to learn and only one operator is required. The entire procedure takes 5 to 10 minutes to complete.
uroNIRS 2000 is a compact and portable standalone system. Optimized specifically for the urologist office setting, the uroNIRS 2000 device has been designed with ease of use in mind. There are 5 main components. The base station controls all the near-infrared lasers and electronics. The base station also charges the tablet PC's battery. The USB port at the back of the base station can be used to connect to peripheral devices, such as a USB memory key or printer, while the tablet PC is docked to transfer or print out patient reports as required. The tablet PC is wireless and runs the uroNIRS software that enables the diagnostic evaluation and patient data management. It displays data received from the base station and the uroflow meter through a secured Bluetooth connection. Because it is wireless, this allows you the freedom of mobility if required during patient voiding. The optical sensor cable carries near-infrared light to the detrusor and detects light returned. The detected light is converted to an electrical signal that is transmitted back to the base station for analysis. A single-use disposable patch connects to the sensor and adheres to the patient's abdomen, just above the pubic bone. The patch is a self-adhesive for ease of use. The calibration analyzer is an accessory that is used to regularly test a sensor cable to ensure its optimal performance.
Before starting the procedure, the system needs to be properly set up. You should make sure that the power cable is connected and that the sensor cable's optical connectors are securely fastened to the laser emitters on the base station. Turn on the base station, tablet PC, and uroflow device. The uroNIRS software will automatically launch when the tablet PC is powered on. Check that the green and blue LED indicators are displayed on the main screen of the tablet PC as well as on the base station. The uroflow device logo should also be visible on the tablet PC. If the uroflow device is not properly connected, a red X will be displayed over the logo, which indicates a faulty connection. Now we will go through the 4 key steps to conduct the uroNIRS 2000 procedure. To start, simply click the Select Session button. Here you may either add a new patient or select from a list of existing patients. If you click on the list of existing patients, you will have access to data from previous sessions. For the purposes of this demonstration, we will add a new patient by clicking this Add Patient button. You are now prompted to fill in several fields pertaining to patient information. Once the patient information has been filled in, you will be prompted to validate the patch. To do this, hold the patch envelope along the right side of the tablet PC and click OK on the screen. Once validated, a message will pop up indicating the patient ID and expiry time for the patch. Simply take the patch out of the envelope and attach it to the sensor. Peel off the adhesive backing. Proper placement of the patch is critical for the test. Have the patient in the supine position. The optimal spot for the sensor is approximately 2 centimeters superior to the pubic bone, centered along the midline and with the notch pointing inferiorly. To do this, align the bottom edge of the patch along the top of the patient's pubic bone. Press down on the patch to make sure it is in full contact with the skin. The purpose of doing this is to shield the sensor from ambient light. Some patients may need to be shaved prior to the test to ensure that there are no gaps between the patch and the skin. It may also be helpful to reduce the lighting in the room. After the patch is placed, the patient can then take the voiding position. It is important to instruct the patient to keep still throughout the test.
Are you ready? Please remain still during voiding.
You may begin the test by selecting Start. All 4 channels are now being monitored to establish a baseline. At the top, concentration tracings for hemoglobin, deoxyhemoglobin, and total hemoglobin of the detrusor are shown. The bottom tracing displays the uroflow meter reading. Once a baseline has been established, you may instruct the patient to begin voiding and at the same time tap the Permission to Void event marker. As soon as urine flow is detected, the changes to uroflow data will be displayed in real time. During the test, you can annotate events by clicking on the predefined event buttons or add comments with the custom event button. When urination stops, click the Stop button to end the session and save the data. The next step is to measure the post-void residual volume and enter this PVR measurement when prompted. Click the Summary Report button to automatically generate a diagnosis report. You may print the report or save a copy on the computer. This report contains the session information, patient information, NIRS, uroflow, and ultrasound data. NIRS, Qmax, and PVR data are applied to a proprietary algorithm to determine whether an obstruction exists. Patients will be classified as either obstructed or unobstructed. This concludes the NIRS testing. As you can see, this non-invasive procedure requires only 1 operator and takes less than 10 minutes to complete.